All right, everybody, this is our last lesson for this unit, 4.4, Intercept Form. Our last lesson, we talked about vertex form, and we could easily find the vertex. For this lesson, we're doing intercept form. What do you think we could find really easy? Well, I think you'll probably find out. So we're going to start by doing what's called a problem string. We're going to build bit by bit until we kind of find what we're trying to look for at the end, if that makes sense. So, first off, what's 2 times 0? Actually, you probably should even just pause and see what you can come up with. Okay? All right, hopefully you gave that a try. So 2 times 0, you'd probably agree that would be 0. 2 times 3 times 0, it'd still be 0. Negative 3 times 4 times 5 times 0, it's still 0. So no matter what everything else is, whatever this is, it doesn't matter as long as one of those numbers is 0. Okay? So let's kind of use that information to answer these questions. So 2 times x is equal to 0, so what does x have to be? Well, we just kind of had a problem very similar to that. So x has got to be 0, because 2 times 0 would give you 0. All right, now this one's a little different. 2 times x minus 3 equals 0. So obviously 2 isn't 0, so that means that this has to be 0. So how would we make that be 0? Well, x would have to be 3. All right, does that kind of make sense? So our total left side has to be equal to 0. And obviously 2 isn't 0, so the other thing that we have has to be 0. So we could do x minus 3 equal to 0, and we could just solve 3 plus 3 to both sides, and we would get that x is equal to 3. And if you plug that back in, 3 minus 3 is 0, and 2 times 0 is 0. Okay, so what about the next one? Why don't you give that a try if you haven't yet? Obviously 2 isn't 0, so what does x need to be to make that be 0? So hopefully you said, oh, it's got to be negative 2. All right. All right. So if we have two things being multiplied and it's equal to 0, then, one of them has to be 0. Okay? So here's another example. What if we had x times x minus 1 is equal to 0? So what would make that work? Or what if we had x plus 2 times x minus 3 is equal to 0? Then what does x have to be? All right? So either this has got to be 0 or this has got to be 0. Right? Because if one of those is 0, then the whole thing is 0. So here x would have to either be negative 2 or positive 3. That was not written very well. Okay, or for this first one, either this has got to be 0 or this has got to be 0. So either x has got to be 0 or x minus 3 has got to be 0. So our solutions here could be 0 or positive 1. Okay. All right, so basically that is what the zero product property says. Hang on. Paste. No. Yeah, I always have a hard time getting that. Okay. All right. So if we're multiplying two things, say A and B could be anything. It could be A and B could be x minus 3, and B could be x plus 7. Okay. If we have two things that are being multiplied by itself, or together, and it's equal to 0, then A has got to be 0 or B has got to be 0. And I think that kind of makes sense if you think about that. So either A 0 or B 0, or they both could be 0. So basically, like, this is like an A, and this is like B. So those have got to be, one of those has got to be 0 to make the whole equation be 0. All right, so let's use that information to kind of solve these equations. So what are our solutions? What would we have to do to end up getting our solutions? So either x minus 5 has got to be equal to 0, because if it's 0, then the whole thing goes to 0. So if we added 5 to both sides, we'd get x is equal to 5. So that's one of our solutions, x is equal to 5. Or this has got to be 0, so x plus 1 has got to be 0. And our other solution would be a negative 1. Okay? You'll kind of notice that it's just like the opposite sign of what's inside those parentheses. So here's another example. So if either x plus 2 has got to be equal to 0, or x plus 8 has got to be equal to 0. And we would subtract 2 to both sides, and we get x is equal to negative 2, or we could subtract 8 from both of those, and we would get x is equal to negative 8. All right, what about D? We have a coefficient, but just like we had like some of those at the very beginning, it doesn't matter what else it is. Okay, if this is 0, then the whole thing's 0, or this is equal to 0, and the whole thing is 0. So our two solutions here would be positive 3 and negative 11. All right, here's another one. We kind of looked at that above. So either this has got to be 0, or this has got to be 0. So either x is equal to 0, or positive 4. Those are the things that you could plug in, and you would end up getting 0. You could even try it if you wanted to. You could plug 0 in for x. You get 0 times 0 minus 4. And you'd get 0 times negative 4, which is 0. Or we would get 4 times 4 minus 4 equals 0. And we get 4 times 0. And that is true. 0 is equal to 0. Okay, I guess I should have done that there too. All right, so you can always plug those back in, kind of see that it works. All right? All right, these last two, we kind of need to be careful with this. All right, it wasn't just like, a lot of the ones were really easy, but now we're kind of looking at this and we have to say either that's got to be 0, so 2x plus 2 has got to be 0, or x minus 5 is equal to 0. So the right side, one step, just add 5, we get x is equal to 5. For this one, it's not as easy to think about it. It's not the opposite of that. If we plug negative 2, we wouldn't get 0. So now we have like a coefficient that's going to kind of mix it up a little bit, but we could still subtract 2, and then we'll divide both sides by 2. So we would end up getting x is equal to negative 1. So those are our two solutions. X is equal to negative 1 and 5. So here's one where we have another that's just very similar. So here we would, that's either equal to 0 or that's equal to 0. So we could add 2 and divide by 3. So I don't know, maybe I shouldn't kind of go shortcut-ish. So we'd add 2. So we get 3x equals 2, and then we divide both sides by 3. So that's one of our solutions. The other, we would add 2 to both sides, and we would get x is equal to 2. So our solutions are x equals 2/3 and 2. All right. So that is how we can solve intercept from intercept form. Oftentimes our equations will be written more like these, where it's y equals, but if we want to solve, we just need to set y equal to 0 and solve. All right, so this is the intercept form. So y equals, they all start with y equals, and then we have a, it's the same a that we used before. And then we have x minus p and x minus q. All right, where p and q are your x-intercepts / solutions, just like we did above. So from the intercept form, list all the key features that can be found without any calculations. Again, this will be on your test. We can easily find our x-intercepts. Okay, that's your p and q. As you notice, this is a negative p and negative q. Our x-intercepts are positive p and positive q. So when we pull those out, when we pull out those x-intercepts, they're going to be the opposite of what you would think. Again, x's tell lies. We can also find end behavior from A, and we can also find the direction of opening from A. All right. So this says identify the x-intercepts from each equation. Make sure you write your intercepts as coordinate points, x comma y's. All right. So here, again, it's the opposite of what you'd think. So one of our x-intercepts would be 5, 0, and the other would be -1, 0. So here we would have one of ours would be 0, 0. Okay. All right, maybe I should preface that. Okay, so we could rewrite this using the 2 parentheses. This would be like negative as our a value, and then we do x plus 0 and x plus 6. Okay, so here we have 0, 0 and -6, 0. Those would be our x-intercepts. So don't get worked up if it doesn't look exactly how the form is. We can always make it look like it. All right, here's a couple others. Again, the a value is not going to affect your x-intercepts. So we have 3, 0 and -2, 0. Here we would have same sort of thing. We would need to, actually what we'd probably want to do is you would want to factor out the greatest common factor. So we could factor out that 2. We can divide this all by 2. So y is equal to 2, x plus 1, and x plus 7. So our x-intercepts would be -1, 0 and -7, 0. Okay, so if you kind of look at that and look at what we had above, again, that kind of helps us realize again that our x-intercepts are our solutions. So like a here, where x is 5 and -1, here we have 5 and -1. Okay, so those are kind of the same. All right, last thing we need to talk about is graphing from intercept form. And this isn't too bad. I already wrote the steps so we could save a little time, but we'll kind of just go we'll just go through it, okay? So first off, what you're going to want to do is you're going to find, we're going to find and plot our x-intercepts, okay? So again, x's tell lies, so our x-intercepts are going to be 1, 0 and -3, 0. So we'll plot those there and there. And then the next step is to find the axis of symmetry. Well, it's really easy because parabolas are symmetric, which means that we know that the axis of symmetry is halfway between those points. Okay? So our axis of symmetry here, our axis of symmetry is x equals -1. All right, and we want to find the vertex now. If we have the axis of symmetry, we know the vertex is on that line. If we have an x and we need to find a y, all we do is substitute. So we set x equal to 1, so we have y is equal to -1 minus 1 and -1 plus 3, and just need to solve. So we end up getting y is equal to -2 times 2, which is -4. So that would be our y value for our vertex. This is our x value for our vertex. So -1, -4. And then we'll use our growth pattern. A is 1, so we're going to go up. We're going to go over 1, up 1, over 1, up 3, over 1, up 5. And we'll do it on the other side as well. Okay. And that's it. So just recap, we plot our x-intercepts. We already talked about how to find those. And then our axis of symmetry is halfway between. And then we just plug that axis of symmetry value, that -1, into our equation to find the y for our vertex. And then we get our vertex. Our vertex here is -1, -4. Okay, that comes from those two. All right, so that's the rest of what we're talking about. I'll go over those if you want some more examples for A and B. I'll even do the key features below just in case. But that is it for today. All right, so again, first step, x-intercepts. Again, x is till lies. So we have one of 5, 0 and 1, 0. So that is here and here. Our axis of symmetry is halfway between. So that would be at x equals 3. So axis of symmetry is x equals 3. So we have the x value for our vertex, 3, something. If you have an x and you need to find a y, we plug that into our x's. So we'll do y equals 2 times 3 minus 5 and 3 minus 1. We'll end up getting 2 times -2 times +2. And we get y equals -8. So our vertex is 3, -8, which is right here. Growth pattern. So A is 2. So we're going to go 2. Again, it's like 1 times A, 3 times A, 5 times A. So 1 times 2 is 2, 3 times 2 is 6, and 5 times 2 is 10. So we go over 1, up 2, over 1, up 6, which we already have that there. So that's a good check to make sure that that's where it should be. And over 1, up 10, which is out of the graph. So we're all done. So we'll just connect those dots the best that we can. Kind of missed that one, but it's okay. Okay, and now we can do our key features. So x-intercepts, we already have those written above. That was 5, 0, and 1, 0. Our y-intercept, again, I can't see it, but our pattern went over 1, up 2, over 1, up 6, over 1, up 10. So if we had it higher, it would go at 10. So our y-intercept would be 0, 10. Again, if you're not sure and you wanted to use your equation, we could set x equal to 0. So 2 times 0 minus 5 and 0 minus 1 would get 2 times -5 times -1, which gives us 10. Okay, so we could always do that. Axis of symmetry, which we already found, which was x equals 3. Nice thing about intercept form is you calculate all of the key features, or most of them, when we're trying to graph. Vertex, we found that already, 3, -8. Max or min, here we have a minimum value of -8. Domain, as always, -infinity to infinity. Range, how low to how high, so -8 included, all the way to infinity with a parenthesis. Increasing, again, is where we have positive, oops, I didn't want to use that one, positive slope. So that would be everything right of the axis of symmetry. So that would start at 3 and goes to infinity. And decreasing would go from -infinity to 3. Positive, again, is all the lines above the x-axis. So that would go from negative infinity to 1. And it would also be from, what is that, 5 to infinity. And negative is this portion. So that's from 1 to 5. And then end behavior, the arrows are going up to infinity, so the y is going to infinity. So as x goes to infinity, y goes to infinity. And as x goes to negative infinity, y goes to infinity. Okay? All right, and then we'll graph this last one. I'll probably leave the key features just to save some time on the video. All right, so again, we could rewrite this if you wanted to as this, if that helps you when you write down your x-intercepts. So we have an x-intercept at 0, 0, and negative 2. So again, maybe I'll just write it down here. So x-intercepts are 0, 0, and negative 2, 0. Again, x's tell lies. Y-intercept, well, we already have that, because that's where the origin is. Okay, but we need to find the axis of symmetry, which is halfway between those points. So that's like at x equals negative 1. And then to find the y for the vertex, so we already have that the vertex is negative 1 comma something. So we plug that into our equation. So y is equal to negative, and we'll do negative 1, and negative 1 plus 2. So we get negative times a negative 1 will give us a positive 1. And negative 1 plus 2 would give us a positive 1. So we end up getting y is equal to 1. So our y-intercept would be right there. And then it makes sense because a is negative 1, we're going to go down. So over 1, down 1, over 1, down 3, over 1, down 5 on both sides. Okay. All right, well, that's basically it for the unit. If you have any questions, please let me know. I'd love to help you.